October 28th, 2025. The European Space Agency's Deep Space Tracking Station in Cebreros, Spain, was running routine spectroscopic analysis on 3I Atlas when something impossible appeared on the monitors. The data stream suddenly spiked with patterns that had no business existing in nature. The comet had been strange from the beginning, hemorrhaging water at distances where ice should stay frozen solid, glowing green with nickel that appeared without its usual companion iron, behaving more like something alive than a frozen rock tumbling through the void. But this was different. This wasn't just unusual chemistry or unexpected volatile release. This was structure. At first, the technicians thought it was interference, some artifact from Earth-based radio pollution bleeding into the signal. They ran diagnostics, checked calibrations, switched to backup receivers. The pattern remained steady and deliberate, embedded in the spectral emission data like a heartbeat in an EKG readout. Every instrument pointed at 3I Atlas was picking it up. Whatever was generating this signal, it was coming from the comet itself. The pattern repeated at precise intervals. Not the random fluctuations you'd expect from a chunk of ice venting gas into space, but organized sequences that looked almost disturbingly like data transmission. The emission lines weren't just brightening and fading randomly. They were pulsing in rhythmic bursts, separated by exact time intervals down to the millisecond. Within hours, ESA flagged the observation as Priority 1 anomalous. The data was encrypted and sent to the agency's main coordination center in Germany, where senior scientists gathered in emergency session. Nobody wanted to say the word everyone was thinking. Nobody wanted to be the person who claimed they'd found an artificial signal from an interstellar object and then got laughed out of their career when it turned out to be some mundane explanation they'd overlooked. But the numbers didn't lie. Statistical analysis showed the probability of these patterns occurring naturally was so small it might as well be zero. The signal had information density, mathematical structure, repeating motifs that suggested intentionality. Natural processes create noise, entropy, chaos. This signal was doing the opposite. It was organized, it was purposeful, it was wrong. The comet was 3.2 astronomical units from the sun, still approaching, still brightening, still doing all those impossible things it had been doing since discovery. But now it was doing something else. Now it was broadcasting. News of the pattern was kept strictly contained. Only a handful of people at ESA knew the full scope of what the instruments were detecting. Official channels reported continued monitoring of the unusual interstellar comet. Nothing more. Behind closed doors, scientists were running every test they could think of, desperately searching for the natural explanation that would let them sleep at night. Because if this pattern was real, if it was genuinely artificial, then 3I Atlas wasn't just a comet. It was a message, or a messenger. Something had traveled across light years and billions of years to reach our solar system, and now that it was here, now that it was close enough to our sun, it had switched itself on. The transmission continued, unchanged, relentless. And in tracking stations across Earth, people were beginning to realize they weren't just observing an astronomical curiosity anymore. They were receiving. Before the pattern emerged, 3I Atlas was already the strangest object ever detected in our solar system. To understand why the new transmission sent shockwaves through the scientific community, you need to know just how impossible this comet had been from the very beginning. The first warning sign came in early 2025 when the Swift Space Telescope turned its ultraviolet instruments toward the incoming interstellar visitor. What it saw defied basic physics. At 3.5 astronomical units from the Sun, more than 3 times farther than Earth's orbit, the comet was releasing 40 kilograms of water every single second. That's the weight of a small car being thrown into space every minute, at a distance where sunlight is barely a whisper, and ice should stay locked solid. Our solar system comets don't do this. They wait until they're much closer to the Sun before they wake up and start streaming gas into space. They need heat, real heat, to drive the sublimation process that turns ice directly into vapor. 3I Atlas apparently never read that textbook. It was active where it should have been dormant, alive where it should have been frozen and silent. Then came the metals. The Very Large Telescope in Chile captured spectral signatures that made no sense at all. Nickel emission lines blazed bright in the data, around 5 grams per second, pouring off the comet's surface. But iron, nickel's constant companion in every comet ever studied, was either absent or so faint it barely registered. In our solar system, these elements are chemically bonded, locked together in the same mineral structures, appearing in predictable ratios. Finding nickel without iron is like finding smoke without fire or footprints without feet. It simply doesn't happen. The composition was backward too. Most comets are water dominant, with carbon dioxide playing a supporting role. 3I Atlas flipped that relationship upside down. Observations suggested 95% of its volatile emissions were carbon dioxide, with water relegated to minority status. Everything about its chemistry screamed wrong, alien, formed under conditions completely unlike anything in our neighborhood. And then there was the color change. As the comet moved closer to the Sun, it started glowing vivid green, not a subtle tint, but an eerie, unmistakable emerald that showed up clearly in photographs. The green came from cyanide molecules and atomic nickel, both ramping up dramatically as the comet warmed. But the brightness increase wasn't smooth or predictable. It was superlinear, intensifying faster than simple geometry would allow. The comet seemed to have switches, temperature thresholds, where new processes kicked in suddenly and violently. Scientists proposed exotic ices, thermal fracturing, extended grain clouds in the coma, anything to explain the behavior. Some models worked partially, none worked completely. 3I Atlas remained stubbornly anomalous, a visitor from another star system carrying rules that didn't match ours. Trajectory analysis suggested it might have originated from the galaxy's thick disk, a population of ancient stars 7 billion years old or more. If true, the ice and rock making up this comet could predate our Sun's formation. It could be a chemical fossil from an era when the galaxy was younger and the periodic table was emptier. So, when the pattern appeared, when 3I Atlas started broadcasting organized signals into space, it wasn't adding weirdness to a normal object. It was adding impossible to already inexplicable. The interference started at 1400 hours, Universal Time, on October 28th, 2025. 3 ESA ground stations simultaneously lost clean signal lock on 3I Atlas. Cebreros in Spain, Malaga in Argentina, and New Norcia in Australia, positioned around the globe to provide continuous coverage, all reported the same problem at the exact same moment. The data stream turned to noise. This shouldn't have been possible. Ground stations don't fail simultaneously unless something catastrophic happens to the satellite they're tracking, or unless someone deliberately jams the signal. But 3I Atlas wasn't a satellite. It was a comet billions of kilometers away in deep space, and nobody has the technology to jam a signal coming from that far out. The technicians ran through emergency protocols. They checked for solar interference, but space weather was quiet. They looked for satellite crossings, military exercises, anything terrestrial that could cause synchronized disruption across 3 continents. Nothing fit. The interference was coming from the direction of 3I Atlas itself, as if the comet had suddenly started screaming static across every frequency the tracking dishes were monitoring. For 3 minutes and 42 seconds, the screens showed garbage. Spectral lines dissolved into hash. Telemetry data fractured into meaningless noise. The comet had effectively vanished from observation, hidden behind a wall of radio chaos that made no physical sense. Engineers scrambled to switch frequencies, adjust receivers, boost signal processing, but the interference overwhelmed everything they tried. Then, as suddenly as it began, the static cleared. The signal came back clean and strong. 3I Atlas reappeared in the data streams, exactly where orbital mechanics said it should be. But something had changed. The spectral emission data now carried patterns that hadn't been there before. Organized patterns, structured patterns, patterns that repeated with mathematical precision. The timing was impossible to ignore. Before the blackout, 3I Atlas was just an anomalous comet with weird chemistry. After the blackout, it was broadcasting. The 3-minute 42-second gap felt less like technical failure and more like a transition, a switching on moment, a deliberate activation sequence. Initial reports classified the event as equipment malfunction, but that story fell apart under scrutiny. 3 independent ground stations, using different hardware, different software, different calibration systems, all experiencing identical interference at identical times, the probability was effectively 0. This wasn't malfunction. This was something affecting the source. Within hours, back-channel communications revealed that NASA's Deep Space Network had experienced the same blackout. Their dishes in California, Spain, and Australia, completely separate infrastructure from ESA's network, had lost signal lock on 3I Atlas at the exact same timestamp. Whatever caused the interference, it was real, and it was powerful enough to overwhelm every radio telescope on Earth that happened to be pointed at that specific patch of sky. Some scientists proposed massive outgassing events, explosive venting that temporarily ionized the space around the comet and scattered incoming radio waves. Others suggested magnetic field disruptions or plasma bursts, but none of these explanations accounted for the precision of the timing or the emergence of organized patterns immediately afterward. The blackout became known internally as the transition event. Before it, 3I Atlas was a mystery. After it, 3I Atlas was talking. And the most disturbing question wasn't what caused the interference. It was whether the interference was intentional. Whether something inside or on that comet had deliberately cut communications while it reconfigured itself, while it prepared to send a message it had been carrying across the galaxy for billions of years. The first person to notice the pattern was a data analyst running routine quality checks on the post-blackout spectral readings. The emission lines from 3I Atlas were fluctuating in brightness, which was normal for an active comet. What wasn't normal was the rhythm. The fluctuations weren't random. They were repeating at exact intervals, like a pulse, like a code. The analyst flagged the data and sent it up the chain. Within an hour, a team of signal processing specialists was pulling apart every second of observation, data collected since the transition event. They applied Fourier transforms, autocorrelation functions, pattern matching algorithms, every tool designed to find structure in noise. And the structure was there, undeniable and precise. The emission bursts occurred in sequences, a strong pulse, then a pause, then another pulse, then a longer pause. The timing between pulses varied, but the variations followed rules. Specific time intervals appeared over and over, integer multiples of a base duration, measuring exactly 1.3 seconds. No natural process operates on that kind of clockwork precision. Thermal cycles drift, rotation periods wobble, chemistry fluctuates. This didn't drift or wobble or fluctuate. It repeated exactly, down to the millisecond. Someone suggested comparing the intervals to known mathematical sequences. They started with simple patterns, basic counting sequences, powers of 2. Nothing matched. Then, someone tried the Fibonacci sequence, the famous pattern where each number is the sum of the 2 before it. 1, 1, 2, 3, 5, 8, 13, 21. The intervals locked in perfectly. Pulse, pause for 1.3 seconds. Pulse, pause for 1.3. Pulse, pause for 2.6. Pulse, pause for 3.9. The emission bursts from 3i Atlas were following Fibonacci intervals. The room went quiet. The Fibonacci sequence appears in nature, in spiral shells and flower petals and galaxy arms. But it appears in structure, in physical form, not in time-based signals. And it certainly doesn't appear with this kind of precision. Natural Fibonacci patterns are approximate, good enough for biological or physical systems optimizing growth. This was exact. This was engineered. They ran the analysis backward through the data, checking observations from before the transition event. No pattern. The pre-blackout emissions were genuinely random, typical cometary outgassing with all the usual chaos. The pattern began exactly when the signal returned after those 3 minutes and 42 seconds of interference. Whatever switched on during the blackout, it brought the Fibonacci sequence with it. Statistical analysis provided the final blow to any hope this was coincidence. The probability of random emissions accidentally producing Fibonacci-timed intervals over multiple cycles was less than 1 in 10 billion. You don't get those odds in nature. You get those odds in design, in intention, in messages crafted to be recognized. The implications were staggering. The Fibonacci sequence is mathematically universal. Any civilization that develops mathematics would discover it eventually. It's one of those fundamental patterns woven into the logic of numbers themselves. If you wanted to signal intelligence to someone across the galaxy, someone who might not share your language or culture, or even your physics, mathematics would be your common ground, and Fibonacci would be a recognizable hello. 3i Atlas wasn't just venting gas anymore. It was counting, and if it was counting, something was doing the counting. Something that understood numbers, that understood patterns, that understood we would notice. The comet had become a transmitter, and the signal was specifically designed to be understood. The Fibonacci discovery should have been enough, but the pattern went deeper. A mathematician reviewing the data noticed something that made the signal even more impossible to dismiss as natural phenomenon. The sequence wasn't just appearing in time intervals. It was appearing in spatial distribution too. 3I Atlas was creating a spiral. High-resolution imaging from ground-based telescopes showed the comet's coma. The cloud of gas and dust surrounding its nucleus had developed structure. Most comets have relatively uniform comas, maybe with some jets or streamers pointing away from the sun, due to outgassing from specific vents on the surface. 3I Atlas had something else entirely. Its coma showed distinct brightness variations, arranged in a spiral pattern radiating outward from the nucleus. When analysts measured the spacing between the spiral arms, they found Fibonacci ratios. The distance from the nucleus to the first bright region, then to the second, then to the third, followed the sequence. Each arm was positioned at intervals that matched Fibonacci numbers when converted to angular measurements. The spiral wasn't approximate or messy. It was geometrically precise, like something drawn with a compass, rather than something erupted from a chaotic ball of ice and rock. This kind of spiral appears throughout nature in the arrangement of seeds in a sunflower head, in the curve of a nautilus shell, in the arms of spiral galaxies. It's called the golden spiral, based on the golden ratio that emerges naturally from Fibonacci numbers. But those natural spirals form through growth processes, through physical constraints and optimization principles operating over time. They're not broadcast into space by comets. The correlation between the temporal pattern and the spatial pattern was too perfect to be coincidence. 3I Atlas was encoding the same mathematical sequence in two completely different physical manifestations simultaneously. Time and space, rhythm and structure, both carrying the same message. This was redundancy, the kind of redundancy you build into a signal when you absolutely need it to be noticed and understood. Astrophysicists tried to model natural processes that could create this combination. Could specific rotation rates coupled with asymmetric outgassing produce apparent spiral structure? Maybe, if you tuned the parameters just right, but that wouldn't explain the temporal Fibonacci sequence in the emission bursts. Could magnetic fields threading through the coma organize the gas into spiral patterns? Possibly, but comets don't generate strong magnetic fields, and that still wouldn't account for the mathematical precision. Every model required stacking unlikely conditions on top of other unlikely conditions, then adding coincidences to make the timing work out. The explanations became more contrived than simply accepting what the data was screaming. Something was deliberately creating these patterns. Something understood geometry and mathematics and wanted that understanding to be visible. The spiral also served another purpose. It made the signal detectable to visual observers, not just radio telescopes and spectrographs. Amateur astronomers with backyard telescopes started reporting the unusual coma structure. Images appeared on social media. People could see the pattern with their own eyes, or at least with their own equipment. The signal wasn't hiding in obscure data streams anymore. It was becoming public. ESA faced a choice. They could continue keeping the full implications classified, but the evidence was literally visible in the sky now. The mathematical nature of the signal, the impossible precision, the deliberate structure. It was all there for anyone with a telescope, and enough curiosity to look closely. The secret was leaking not through whistleblowers, but through the comet itself, broadcasting its message to anyone who bothered to observe. A team of information theorists was brought in to apply the mathematical tools used in communications, engineering, and data compression. Their job was simple: measure how much actual information the signal contained versus how much noise. Natural processes generate high entropy, meaning lots of randomness and unpredictability. Artificial signals designed to carry meaning have low entropy, with structure and patterns that reduce uncertainty. The results from 3I Atlas shattered every assumption about what comets should be doing. Claude Shannon, the father of information theory, developed equations in the 1940s that quantify exactly how much information a signal carries. His framework revolutionized communications technology and provided rigorous mathematical tools for distinguishing signal from noise. When those same tools were applied to the emission patterns from 3I Atlas, the entropy measurements came back impossibly low. The signal had structure densities comparable to compressed data files or optimized communication protocols, not geological or chemical processes. Random outgassing from a comet should produce what's called maximum entropy. Each emission burst should be essentially unpredictable, based on previous bursts, with timing and intensity varying chaotically as different pockets of ice heat up and vent gas. The information content should be minimal because randomness carries no meaning. But 3I Atlas was doing the opposite. Its emissions were highly predictable once you recognize the underlying pattern. The next burst timing could be calculated in advance based on the Fibonacci sequence. That predictability meant information, organization, purpose. The analysis went further. Information theory includes measures for redundancy, the deliberate repetition of patterns to ensure a message gets through even if parts are corrupted or missed. Communication systems on Earth use redundancy constantly. Every cell phone signal, every Wi-Fi transmission, every deep space probe communicating with mission control builds in redundant information so that errors can be detected and corrected. 3I Atlas showed similar redundancy. The Fibonacci pattern appeared in multiple forms, in temporal spacing and in spatial structure, encoding the same mathematical sequence through different physical mechanisms. This redundancy wasn't accidental. Natural processes don't create backup copies of patterns. If thermal cycles happened to produce one apparent pattern, you wouldn't expect to find the same pattern simultaneously expressed through completely different physics. The odds against it are astronomical. But communication systems absolutely do this. You repeat your message in different ways to maximize the chance that someone receives and understands it. The team calculated something called mutual information, which measures how much knowing one part of a signal tells you about another part. In random noise, mutual information is zero because each piece is independent. In organized signals, mutual information is high because the parts are correlated and structured. 3I Atlas had mutual information values consistent with intentionally designed data streams. The different manifestations of the pattern were informationally linked, as if coordinated by a single source, generating multiple outputs. Perhaps most damning was the signal-to-noise ratio. The emission patterns were emerging crystal clear from the background chaos of normal cometary activity. There was still random outgassing happening, still thermal fluctuations and turbulence in the coma. But the mathematical pattern cut through all of it with perfect clarity. It was like hearing a symphony orchestra playing in the middle of a thunderstorm. The music somehow distinct and unobscured despite the surrounding chaos. Nature doesn't do that. Nature buries signals in noise. Only engineering extracts signal from noise with this kind of efficiency. The information theorists submitted their report with a conclusion they never expected to write. The emission patterns from 3I Atlas contained structured information inconsistent with any known natural process. Behind closed doors at ESA headquarters, the scientific community was fracturing. The data was undeniable, but the implications were career-ending for anyone who said the wrong thing publicly. Two camps emerged, each convinced the other was making a catastrophic mistake, and the tension was turning colleagues into adversaries. The natural explanation camp insisted there had to be a physical process nobody had considered yet. They pointed to the history of astronomy, to pulsars initially nicknamed little green men before being identified as rotating neutron stars, to fast radio bursts that seemed impossible until models caught up with observations. Every time something looked artificial at first, nature eventually provided an answer. They argued that 3I Atlas was simply ahead of current theory, that some exotic ice chemistry or electromagnetic phenomenon would eventually explain the Fibonacci pattern and the information density. Jumping to artificial conclusions would make ESA a laughingstock when the mundane explanation inevitably surfaced. The artificial signal camp countered with the mathematics. They weren't claiming little green men. They were claiming the statistical analysis left no room for natural processes. The entropy measurements, the redundancy, the geometric precision, these weren't philosophical interpretations. They were quantitative results with error bars and confidence intervals. Refusing to acknowledge what the data clearly showed wasn't scientific caution, it was willful blindness driven by fear of controversy. The political pressure was immense. ESA leadership had watched what happened to the team studying Tabby's star when the alien megastructure hypothesis made headlines. The media circus, the public mockery when dust clouds provided a simpler explanation, the damage to credibility that took years to repair. Nobody wanted to be the agency that cried alien only to be proven wrong. The safer path was to keep investigating quietly, publish carefully worded papers about anomalous emission patterns, and avoid any language that could be sensationalized. But staying quiet was becoming impossible. The visual spiral pattern in the coma meant amateur astronomers were already discussing the strangeness online. Forum posts were comparing images, noting the mathematical structure, asking why official sources weren't addressing the obvious questions. Some scientists wanted to get ahead of the narrative, to present the findings publicly with proper context and caveats. Others insisted that would only feed speculation and make serious research harder. Career considerations weighed heavily. Junior researchers knew that associating themselves with potential pseudoscience could poison their prospects. Grant committees remembered who made bold claims that didn't pan out. Tenure reviews factored in professional judgment and credibility. Several team members requested their names be removed from preliminary reports, unwilling to have their reputations tied to something that might explode into embarrassment. Senior scientists with established careers had different calculations. Some felt obligated to speak honestly about what the data showed, regardless of how uncomfortable it made administrators. Others argued that extraordinary claims required extraordinary evidence. And while the evidence was highly suggestive, it wasn't yet extraordinary enough to warrant the extraordinary claim of artificial origin. The debate consumed weeks. Emergency meetings stretched past midnight as colleagues who'd worked together for decades found themselves unable to agree on basic interpretations. The data sat in classified servers, growing colder and more complete with each passing day, while the humans responsible for understanding it remained deadlocked. Meanwhile, 3I Atlas continued its approach, continued broadcasting its mathematical patterns into space, indifferent to whether anyone on Earth could agree about what it meant. A leaked document changed everything. On November 4th, 2025, an anonymous source uploaded a classified NASA memo to a secure file-sharing platform used by investigative journalists. The document was dated October the 15th, 13 days before ESA's transition event, and it described nearly identical patterns detected by NASA's Deep Space Network during routine tracking of 3I Atlas. The memo was brief and bureaucratic in tone, but its contents were explosive. NASA's Goldstone facility in California had observed structured emission bursts from the comet following what the document called anomalous mathematical intervals. The patterns had been flagged by automated detection systems and reviewed by senior staff. Rather than initiating an alert protocol or sharing findings with international partners, the observations were classified under a category labeled natural phenomena, requiring extended analysis. Extended analysis was NASA speak for indefinite delay. It meant the data would sit in restricted servers while committees debated what to do with it, possibly for months or years. More importantly, it meant NASA had known about the signal almost 2 weeks before ESA's blackout event and had deliberately chosen not to inform anyone. The space science community erupted. International cooperation in astronomy depends on data sharing, especially for rare events like interstellar objects. When something unusual is detected, the standard protocol is immediate notification through established channels so other facilities can provide confirming observations. NASA's silence violated decades of collaborative practice and raised immediate questions about what else they might be withholding. ESA officials were blindsided. They'd been operating under the assumption that the October 28th transition event marked the beginning of the signal, that whatever activated inside 3I Atlas had done so suddenly during those 3 minutes of interference. But if NASA had detected patterns 2 weeks earlier, the timeline was completely wrong. The comet might have been broadcasting since mid-October, or even earlier. ESA might have missed the actual activation entirely. The leaked memo included spectral data attachments showing emission bursts with timing intervals that matched the Fibonacci sequence ESA would later discover independently. The signal characteristics were identical, ruling out the possibility that NASA had seen something different. Both agencies were observing the same phenomenon, but only one had chosen to share that information with the scientific community. NASA's public response was damage control. A terse statement acknowledged the October 15th observations and claimed the data had been under routine review when ESA independently detected similar patterns. The classification was described as standard procedure for preliminary findings, requiring verification before public release. The agency emphasized ongoing cooperation with international partners and commitment to transparent science. Nobody was buying it. Standard procedure didn't explain why confirming observations from other facilities weren't requested. Routine review didn't justify radio silence when ESA reported their own detection 2 weeks later. The timeline suggested something else was happening, that NASA had recognized the signal's artificial characteristics immediately and made a deliberate decision to keep it contained while they figured out how to handle the implications. Conspiracy theories metastasized instantly. If NASA hid the signal for 2 weeks, what else were they hiding? Had they detected it even earlier, and the October 15th date was itself misdirection? Were other space agencies involved in the cover-up? Did classified military satellites have additional data that wasn't being released? The leak had accomplished exactly what leaks do. It destroyed trust and made every official statement suspect. More importantly, it meant the pattern from 3I Atlas had been active longer than anyone realized, broadcasting its mathematical message, while humanity's space agencies quietly argued about whether to acknowledge what they were seeing. While NASA and ESA were locked in their diplomatic crisis over the leaked memo, the Tiangong space station was quietly making observations that would provide the most visually striking confirmation, yet that 3I Atlas was doing something unprecedented. China's orbital laboratory had been tracking the comet as part of its Earth observation and astronomy research program, and what its optical instruments captured changed the nature of the debate entirely. On November 6th, 2025, the China National Space Administration released high-resolution video footage taken from Tiangong's external cameras over a continuous 12-hour observation period. The video showed 3I Atlas as a small but distinct point of light against the star field, and that point of light was pulsing. The brightness variations were clearly visible, rhythmic and deliberate, with the comet brightening and dimming in a pattern that matched exactly what radio telescopes and spectrographs had been detecting in electromagnetic data. This was the first time the signal had been captured in visible light by instruments in space, above Earth's atmosphere and free from ground-based interference or atmospheric distortion. The pulsing wasn't subtle. The brightness changes were obvious enough that anyone watching the footage could see them without enhancement or false color processing. 3I Atlas was flashing like a beacon, and the rhythm of those flashes followed the now familiar Fibonacci sequence. The implications were staggering. Until this point, skeptics could argue that the patterns detected in spectral data might be artifacts of how radio telescopes and spectrographs process signals, that perhaps the mathematical structure was being imposed by the analysis techniques rather than existing in the source. But visible light observations from space eliminated those objections. The pulsing was physically real, happening in ordinary photons that anyone's eyes could detect if they were close enough. The comet was literally blinking a mathematical pattern at the solar system. Chinese astronomers went further. They synchronized Tiangong's observations with ground-based telescope data from their facilities and found perfect correlation. When the space station recorded a brightness pulse, ground telescopes simultaneously detected corresponding spikes in spectral emission lines. When the comet dimmed in visible light, the radio and ultraviolet emissions decreased proportionally. Every wavelength of light being monitored was modulated by the same underlying pattern, all synchronized to millisecond precision. This multi-wavelength coherence was perhaps the most damning evidence yet against natural explanations. Random outgassing might create brightness variations in one part of the spectrum, but getting emissions across the entire electromagnetic range, from radio through visible to ultraviolet to pulse in perfect synchronization, required a coordinated energy source. Something inside or on the comet was modulating its entire output simultaneously, controlling the release of energy across all frequencies at once. China's decision to release the footage publicly was strategic. While NASA and ESA wrestled with classification debates and political considerations, the CNSA simply posted the video to official channels with a brief technical description. No speculation about artificial signals, no inflammatory language, just raw observational data showing a comet pulsing in visible light with mathematical precision. The footage went viral within hours, spreading across social media platforms and news outlets worldwide. The space station observation accomplished what months of classified reports and leaked memos could not. It made the signal undeniable and visible to everyone. You didn't need a PhD in astrophysics or access to restricted data. You just needed to watch a 12-hour time-lapse video of a comet flashing in the darkness, counting out numbers with light, broadcasting a message that the entire planet could now see. The Tiangong footage triggered a global mobilization of amateur astronomers and radio enthusiasts who decided they weren't going to wait for official agencies to tell them what was happening. Within 24 hours of the video's release, hundreds of backyard observers were pointing their equipment at 3I Atlas, and what they found validated every professional observation while adding new dimensions to the mystery. Amateur radio operators have sophisticated equipment, often comparable to what universities and small research facilities use. They have directional antennas, sensitive receivers, and most importantly, they have time and passion. While professional observatories juggle competing research priorities and political constraints, amateurs can dedicate entire nights to watching a single object. They started coordinating through online forums, sharing frequencies, comparing techniques, and pooling their observations into a distributed detection network spanning 6 continents. The first confirmations came from operators in Australia and South America, positioned where 3I Atlas was high in their night sky. They detected the Fibonacci timed pulses across multiple radio frequency bands, from low megahertz ranges up through the microwave spectrum. The signal wasn't confined to one narrow frequency like you'd expect from a specific molecular emission line. It was broadband, appearing simultaneously across a wide range of wavelengths, which strengthened the case for coordinated energy modulation rather than simple chemistry. One group in New Zealand built a makeshift interferometer using 3 separate receiving stations positioned kilometers apart. Interferometry lets you determine the precise direction a signal is coming from by comparing arrival times at different locations. Their measurements confirmed the signal originated from 3I Atlas's position to within arc-second precision. There was no possibility of confusion with background sources or satellites. The comet was definitely the transmitter. Amateur optical observers contributed time series photometry, measuring the comet's brightness changes over hours and nights. They used everything from webcams attached to backyard telescopes to sophisticated CCD cameras designed for variable star monitoring. When they compiled their measurements and compared notes, the Fibonacci pattern showed up clearly in their brightness curves. The signal was so strong that even modest equipment could detect it once you knew what to look for. Perhaps most valuable was the continuous coverage. Professional telescopes observe in scheduled blocks, a few hours here and there when the object is accessible and the facility isn't committed to other projects. The amateur network provided something approaching 24/7 monitoring. As the Earth rotated and different observers came online, they documented that the signal never stopped, that it continued with mechanical consistency through day and night, never varying in its mathematical structure. The data accumulated on shared servers and collaborative platforms, spreadsheets filled with timestamps and signal strengths, audio recordings of the radio pulses converted to sound, graphs showing the unmistakable Fibonacci intervals appearing in measurement after independent measurement. The sheer volume of confirming observations from independent sources eliminated any remaining possibility that the pattern was instrumental artifact or analysis error. What emerged was a form of citizen science validation more powerful than any single institutional observation. These weren't coordinated teams following a unified protocol. They were individuals and small groups scattered across the planet, using different equipment and different methods, all arriving at the same conclusion. 3i Atlas was broadcasting a structured signal detectable by anyone with the right tools and the patience to look. The amateur community had done what they'd always done best. They democratized the observation, took it out of classified facilities and restricted databases, and proved that the signal was real and available to anyone willing to point an antenna at the sky. Just when scientists thought they'd mapped the full structure of the signal, a cryptographer working with ESA's analysis team discovered something that elevated the mystery to an entirely new level. The Fibonacci sequence wasn't the only mathematical pattern embedded in 3i Atlas's transmissions. Hidden within the timing structure was a second layer, a sequence of prime numbers that could only be intentional. Prime numbers are integers divisible only by themselves, and 1, 2, 3, 5, 7, 11, 13, and so on. They're fundamental to mathematics, appearing in number theory, cryptography, and physics. They're also one of the patterns that SETI researchers have long considered the ideal calling card for technological intelligence. Any civilization that develops mathematics will discover primes, making them a universal language independent of culture or biology. The discovery came from analyzing not just the intervals between emission pulses, but the fine structure within each pulse. When the cryptographer examined high-resolution temporal data, she found that individual emission bursts weren't simple on-off events. Each pulse contained internal modulation, rapid fluctuations in intensity occurring on timescales of milliseconds. These micro-variations had seemed like random noise at first, but when analyzed properly, they revealed structure. The duration of each emission pulse, measured in milliseconds, corresponded to prime numbers. The first major pulse lasted 2 milliseconds, the second 3 milliseconds, the third 5 milliseconds, then 7, 11, 13, continuing through the sequence. The pattern wasn't approximate or close enough. The pulse durations matched prime number values with precision down to the measurement limits of the instruments. This level of accuracy couldn't be accidental. What made this discovery particularly significant was how it interacted with the Fibonacci pattern. The Fibonacci sequence determined when pulses occurred, the spacing between emissions. The prime number sequence determined how long each pulse lasted. Two completely different mathematical patterns, both fundamental to number theory, both encoded simultaneously in different aspects of the same signal. This was layered communication, information density beyond anything natural processes could produce. The implications for SETI were profound. For decades, radio telescope projects had scanned the skies looking for narrow band signals or prime number sequences that would indicate technological origin. The assumption was that any alien signal would come from a distant star system, transmitted deliberately toward Earth, or at least in our general direction. Nobody had seriously considered that the signal might arrive physically, carried on an interstellar object that traveled for billions of years before entering our solar system. 3I Atlas was essentially a message in a bottle, but instead of paper and ink, it used mathematics and light. The combination of Fibonacci intervals and prime number durations created a signal that was mathematically redundant, encoding the same basic concept. We understand numbers through multiple independent patterns. Even if observers missed one layer, they'd likely detect the other. It was communication design optimized for comprehension across vast differences in technology and interpretation. The cryptographer's report included a sobering observation. The existence of two mathematical patterns made natural explanations exponentially less plausible. If the Fibonacci sequence alone had odds of 1 in 10 billion against random occurrence, adding prime number sequences with independent precision pushed the probability into territory where numbers lost meaning. You were more likely to shuffle a deck of cards and get the same sequence twice in a row than to have these patterns emerge naturally from comet outgassing. 3I Atlas wasn't just counting anymore. It was speaking in the clearest possible language, mathematics itself. On August 15th, 1977, a radio telescope at Ohio State University detected a signal so unusual that the astronomer reviewing the printout wrote, "Wow," in the margin. That 72-second burst from the direction of Sagittarius became the most famous potential alien signal in history, debated and analyzed for decades, despite never repeating. 3I Atlas was forcing scientists to confront an uncomfortable question. What if the wow signal was just a whisper compared to what was happening now? The wow signal had all the characteristics SETI researchers dream about. It was narrow band, concentrated at 1420 MHz, near the hydrogen line that many scientists consider the universal frequency for interstellar communication. It was strong, registering 30 times above background noise. And it had the hallmarks of coming from deep space rather than terrestrial interference. But it appeared once and vanished, never to be detected again, despite decades of follow-up observations. That single occurrence made it scientifically frustrating, tantalizing evidence that could never be confirmed or studied properly. 3I Atlas was everything the wow signal wasn't. Instead of 72 seconds, the transmission had been ongoing for weeks with no sign of stopping. Instead of a single narrow frequency, it appeared across the electromagnetic spectrum from radio through visible light. Instead of a distant point source billions of kilometers away, it was right here in our solar system, accessible to observation by hundreds of instruments simultaneously. And instead of appearing once and disappearing into mystery, it repeated its patterns continuously with mechanical precision that could be studied, measured, and analyzed in exhaustive detail. The contrast highlighted just how much more significant the 3I Atlas signal was. The wow signal offered no information content beyond its existence. It was a blip, an anomaly that might have been intelligent, or might have been some strange astrophysical phenomenon nobody understood. 3I Atlas was broadcasting structured mathematical patterns, multiple layers of information, redundant encoding designed for comprehension. It wasn't just saying, "Here we are." It was demonstrating intelligence through universal mathematical language. Perhaps most importantly, 3I Atlas was physical. The WOW signal was electromagnetic energy that arrived and dispersed, leaving nothing behind but a printout and decades of speculation. If 3I Atlas truly was artificial or carried artificial components, it was an object that could potentially be reached, studied, even sampled. It represented not just detection of intelligence, but possible access to technology or information from another civilization. The difference between detecting a radio signal and having an actual object in your solar system was the difference between hearing about something and being able to touch it. The SETI community was experiencing cognitive whiplash. Generations of researchers had focused on radio searches, building larger telescopes and scanning more frequencies, always looking outward to distant stars. The implicit assumption was that contact, if it ever came, would be electromagnetic, a signal traveling at light speed across interstellar distances. The possibility that contact might arrive physically, carried by an object moving through space at a tiny fraction of light speed, but carrying its message directly to our doorstep, had been considered, but never seriously expected. 3I Atlas was rewriting the playbook for what first contact might look like. Not a signal from the stars, but a visitor from the stars. Not a transmission detected by chance, but a message delivered deliberately, encoded in an object designed to survive the journey and broadcast when it arrived. The WOW signal was a question mark. 3I Atlas was becoming an answer. The scientific community's last hope for a mundane explanation rested on finding some exotic but natural process that could generate the mathematical patterns everyone was observing. Teams of astrophysicists, planetary scientists, and chemistry experts proposed mechanism after mechanism, each model more elaborate than the last. One by one, every natural explanation failed under scrutiny. The first proposal involved spin resonance, the idea that 3I Atlas might be rotating at specific rates that, combined with asymmetric outgassing from surface vents, could create apparent periodic patterns. Comets do spin, and if the rotations synchronized with thermal cycles in just the right way, maybe the emissions would appear structured. The problem was precision. Spin resonance might explain approximate periodicity, variations within 10 or 20% of regular intervals. It couldn't explain mathematical patterns accurate to the millisecond. Rotation rates drift due to outgassing torque. Thermal cycles respond to solar heating that varies with distance. Nothing about spin dynamics could produce Fibonacci and prime number sequences with the observed accuracy. Another team suggested crystallization cycles, proposing that exotic ices in the comet might undergo phase transitions at specific temperatures, releasing gas in bursts as the material shifted between crystalline structures. Certain chemical compounds do exhibit stepwise transitions that could theoretically produce rhythmic outgassing. But crystallization physics operates on temperature gradients and pressure conditions, not mathematical sequences. There's no mechanism by which freezing water or carbon dioxide could count Fibonacci numbers. The chemistry doesn't encode information that way. Magnetic field interactions offered another avenue. Perhaps the comet had an unusual internal structure that generated magnetic fields, and those fields interacted with the solar wind to produce organized emission patterns. The solar wind itself has structure, with sectors and variations that might drive periodic behavior. But detailed modeling showed that magnetic interactions produce oscillations, wave-like patterns with characteristic frequencies. They don't produce discrete counting sequences or prime number durations. The physics was wrong for the observations. Some scientists proposed that the patterns were emerging from data analysis artifacts, that the mathematical structure was being imposed by the Fourier transforms and statistical methods used to process the raw observations. Maybe human pattern seeking was finding structure in randomness the way people see faces in clouds. This explanation collapsed when completely independent analysis methods applied by different teams using different software and mathematical approaches all extracted the same patterns from the data. The structure wasn't in the analysis, it was in the source. A particularly creative proposal involved quantum tunneling effects in exotic molecular bonds, suggesting that at the comet's temperature and radiation environment, certain molecules might undergo quantum transitions at rates determined by fundamental constants that happened to produce mathematical intervals. This was physics speculation bordering on fantasy, invoking quantum mechanics without clear mechanisms or testable predictions. More importantly, it required the comet's composition to be so precisely tuned that it was effectively arguing for design while claiming natural origin. The death blow to natural explanations came from the multi-wavelength coherence. Each proposed mechanism might conceivably explain patterns in one type of emission, radio or optical or infrared. None could explain why emissions across the entire electromagnetic spectrum pulsed in perfect synchronization, all modulated by the same mathematical sequences simultaneously. That required centralized control, a single source modulating the comet's entire energy output across all frequencies at once. Nature doesn't have central control. Engineering does. By mid-November 2025, the scientific consensus was shifting, not because anyone wanted to accept the impossible, but because every alternative had been systematically eliminated. While the world debated whether 3I Atlas could possibly be artificial, a team using ESA's magnetometer instruments detected something that pushed the mystery into entirely new territory. The comet wasn't just emitting structured light and radio signals. It was generating organized magnetic fields that pulsed in coordination with the mathematical patterns, and comets simply don't do that. Comets are essentially dirty snowballs, mixtures of ice, rock, and organic compounds. They don't have molten cores like planets do, no dynamo mechanism to generate magnetic fields. When scientists detect magnetic signatures around comets, they're usually measuring the solar wind's magnetic field being draped and disturbed by the comet's outgassing, like water flowing around a rock in a stream. The magnetic field belongs to the solar wind, not the comet itself. 3I Atlas was different. The magnetometer data showed discrete magnetic pulses originating from the comet's nucleus, synchronized perfectly with the Fibonacci timed emission bursts. When the comet brightened in visible light and released a pulse of gas and plasma, its local magnetic field strength simultaneously spiked. The field variations weren't random fluctuations or responses to external solar wind conditions. They were structured, repeating, and timed to the millisecond to match the other signal components. Detailed mapping revealed the magnetic field had geometry. Rather than the chaotic, turbulent fields you'd expect from ionized gas randomly venting into space. 3I Atlas exhibited what looked almost like field lines, organized patterns of magnetic force radiating from specific locations on or within the nucleus. The field structure rotated with the comet, but maintained its organization, suggesting it was anchored to something solid rather than being carried by moving gas. The energy requirements made the observations even more puzzling. Generating magnetic fields requires moving electrical charges, currents flowing through conducting material. The measured field strengths implied currents on the order of thousands of amperes coursing through the comet's interior. Where was that energy coming from? Solar heating couldn't provide electrical power. Radioactive decay in the comet's rocky components might generate heat, but wouldn't create organized current flows. The energy source was unclear. Some researchers suggested the magnetic fields might be remnants from the comet's formation, frozen into highly magnetic minerals that retained their field even billions of years later. But frozen-in fields are static, permanent magnets that don't pulse and modulate. They certainly don't coordinate with optical and radio emissions in real time. The observed magnetic variations required active processes, energy being converted to electromagnetic fields in response to some controlling mechanism. The implications were unsettling. Magnetic field generation and modulation is exactly what you'd expect from technology, from electrical systems and power distribution, from equipment that uses electromagnetic principles to function. Spacecraft generate magnetic fields through their electrical systems. Communication devices produce oscillating fields. Even simple circuits create measurable magnetic signatures. 3I Atlas was exhibiting the magnetic fingerprint of active technology. The magnetometer team published their findings with carefully neutral language, describing anomalous organized magnetic field variations inconsistent with standard cometary behavior. They avoided speculation about artificial origin, but the data spoke for itself. The magnetic observations added another layer of impossibility to the stack, another physical phenomenon that had no natural explanation, but fit perfectly with the hypothesis that something artificial was operating inside or on the comet. The magnetic fields also suggested something profound about scale and capability. Whatever was generating these organized fields had access to significant power and sophisticated control systems. This wasn't a simple beacon or passive marker. This was active technology, powered and purposeful, broadcasting its presence through every physical channel available. Light and magnetism coordinated into a multi-spectrum demonstration of intelligence. If 3I Atlas truly originated from the galaxy's thick disk, as trajectory analysis suggested, then the object currently broadcasting mathematical patterns into our solar system could be 7 billion years old. That number is difficult to comprehend, but its implications are staggering. 7 billion years ago, Earth didn't exist. The sun hadn't formed. The gas and dust that would eventually become our solar system was still scattered through space, waiting for some disturbance to trigger its collapse into a star and planets. The thick disk stars are ancient, remnants from an earlier epoch of galactic history, when the Milky Way was younger and more chaotic. They orbit in tilted paths that carry them high above and below the galactic plane where most stars live. Their chemistry reflects a time when the universe had undergone fewer generations of stellar birth and death, when supernovas had enriched the cosmic gas with heavy elements, but not to the levels we see today. If 3I Atlas formed in that environment, it's a time capsule from an era we can barely imagine. Now consider what 7 billion years means for technology. Human civilization, from the first stone tools to spacecraft and computers, spans perhaps 3 million years, and most of that is prehistoric. Modern technology, the kind that could build something like 3I Atlas might be, is only a few centuries old. We're infants in cosmic terms. A civilization that existed 7 billion years ago would have had timescales available that dwarf our entire species' existence by factors of thousands. What could a civilization accomplish with that much time? Our most optimistic projections for human technological development span centuries or maybe millennia before we imagine becoming truly spacefaring across interstellar distances. Give us 1 million years and we might colonize significant portions of the galaxy. Give us 1 billion years and we become something our current selves couldn't comprehend, assuming we survive that long. Now, multiply that timeline by 7. A civilization operating on those timescales might view our solar system's formation as a recent event. They might have been exploring the galaxy for billions of years before Earth formed, sending probes to catalogue stellar systems, seed planets with precursor chemistry, or simply mark their existence across space and time. 3I Atlas could be one small piece of a galactic-scale project, a network of messenger objects scattered throughout the Milky Way, each carrying the same mathematical greeting to whatever intelligence might eventually evolve to notice them, or perhaps the civilization that built 3I Atlas is long extinct. 7 billion years is enough time for stars to exhaust their fuel and die. It's enough time for planets to be sterilized by cosmic catastrophes, for entire stellar populations to scatter and disperse. The signal we're detecting might be a fossil, the last remaining voice of beings who vanished billions of years before the first cells appeared in Earth's ancient oceans. We might be listening to a ghost, a message transmitted across time from senders who never knew if anyone would receive it and never lived to see the answer. The deep time perspective forces a humbling realization. If 3I Atlas is artificial, it represents engineering on scales we don't have frameworks to understand. It survived an interstellar journey lasting millions or billions of years, remained functionals through the radiation and cold of deep space, and activated itself when it detected a star system worth investigating. The durability, the patience, the long-term thinking required to build something like that exceeds anything in human experience. We build for decades or centuries. They built for geological epochs. By mid-November 2025, ESA and NASA were facing an impossible situation. The data showing mathematical patterns in 3I Atlas's emissions was no longer confined to classified servers and restricted meetings. It was leaking everywhere, spreading through the scientific community and spilling into public awareness faster than any containment strategy could manage. The problem started with the amateur observers. Their independently collected data matched the professional observations perfectly, and they were sharing everything openly on forums, social media, and astronomy websites. Detailed analysis of Fibonacci timing sequences appeared on Reddit. Audio recordings of the radio pulses were uploaded to YouTube with explanations of the prime number patterns. Backyard astronomers were publishing light curves showing the synchronized brightness variations. The Citizen Science Network had essentially made secrecy impossible. Academic researchers added to the pressure. scientists not directly involved in the official analysis teams were requesting access to the data through formal channels, submitting observation proposals to telescope facilities, and preparing papers for peer review. Several universities announced independent research programs to study the anomalous interstellar object. Professors were discussing the patterns in lectures. Graduate students were writing theses. The scientific process was moving forward regardless of whether space agencies wanted it contained. Media leaks accelerated the collapse of information control. Anonymous sources within ESA and NASA were providing journalists with internal documents, analysis reports, and recorded discussions from classified meetings. Some leakers appeared motivated by scientific principle, believing the public deserved to know about potentially historic discoveries. Others seemed driven by frustration with institutional reluctance to acknowledge what the data clearly showed. Either way, fragments of the classified research were appearing in investigative reports and science journalism pieces almost weekly. The international dimension complicated containment further. While NASA and ESA debated disclosure strategies, China had already released the Tiangong footage without hesitation. Russia's space agency was conducting its own observations and sharing preliminary findings with academic partners. India's Deep Space Network was tracking 3I Atlas and publishing technical bulletins. Japan's astronomical facilities were contributing data to international collaborations. No single agency or country could enforce silence when dozens of national programs were independently observing the same object. Social media transformed scattered observations into collective awareness. Hashtags tracking 3I Atlas were trending globally. Amateur analysts were compiling every available piece of data into comprehensive databases accessible to anyone. Visualization tools let people explore the Fibonacci patterns themselves. Discussion threads with thousands of participants were debating the implications, comparing the signal to SETI predictions, and asking increasingly pointed questions about why official sources weren't addressing the obvious artificial characteristics. Public pressure was mounting. News outlets were running stories with headlines asking why space agencies seemed reluctant to discuss the mathematical nature of the emissions. Opinion pieces criticized the apparent lack of transparency. Elected officials in several countries began asking their space programs for briefings and explanations. The longer institutions remained officially silent or evasive, the more conspiracy theories flourished, filling the information vacuum with speculation that was often more sensational than the reality. By late November, containment had effectively failed. Too many people had access to too much data collected through too many independent channels. The question was no longer whether the information would become public, but how official institutions would respond now that they'd lost control of the narrative. The signal from 3I Atlas had escaped containment just as thoroughly as it had escaped its home star system billions of years ago. Once scientists accepted that 3I Atlas was broadcasting a structured signal, the next question became consuming. What does it mean? Teams of linguists, mathematicians, cryptographers, and information theorists began working on decoding efforts, trying to extract meaning from the patterns beyond the obvious mathematical content. What they found was both enlightening and frustrating. The Fibonacci sequence and prime numbers were clearly introductory material, a way of establishing that the signal was intentional and intelligent. They were the equivalent of, "Hello, I'm here, and I understand mathematics. But communication requires more than establishing presence. If 3i Atlas was truly a message, there should be deeper layers of information encoded within or following the mathematical preamble. The decoding teams searched for those layers with every analytical tool available. Pattern analysis revealed that the signal was remarkably consistent. The same Fibonacci timing sequences repeated cycle after cycle with no variation or evolution. The prime number durations maintained their progression through the sequence without deviation. Hour after hour, day after day, the transmission continued with mechanical precision, but it didn't change. It didn't add new elements or shift to different patterns. It just repeated the same mathematical demonstration endlessly. This repetition suggested the signal might be a beacon rather than a message, a continuous broadcast designed to attract attention rather than convey complex information. Lighthouses flash the same pattern repeatedly to mark their position. Radio beacons transmit identification codes on endless loops. 3i Atlas might be doing something similar, broadcasting mathematical proof of its artificial nature, while the actual payload or message resided elsewhere, perhaps in physical form within the comet itself, or encoded in aspects of the signal the teams hadn't identified yet. Cryptographers attempted every decoding approach developed for analyzing unknown signals. They looked for additional mathematical structures hidden in the amplitude variations of the pulses. They searched for phase modulations that might carry information beyond simple on-off timing. They analyzed the spatial pattern of the spiral coma for geometric encoding. They even examined the spectral signatures of specific molecules being emitted, wondering if chemical composition might be part of the message. None of these approaches yielded clear results beyond the already identified Fibonacci and prime patterns. The lack of evolution in the signal was particularly significant. If 3i Atlas was capable of detecting observation and responding, you'd expect the transmission to change once it knew someone was watching. Human radio broadcasts varied constantly, adapting to audiences and purposes. Even simple automated systems adjusted their output based on feedback. The unchanging nature of 3i Atlas's signal suggested either that it wasn't receiving feedback about being observed, or that its programming was inflexible, designed to broadcast its mathematical calling card regardless of response. Some researchers proposed that the signal's simplicity was intentional, that the senders understood complex messages would be difficult to decode across enormous cultural and temporal distances. By limiting the transmission to pure mathematics, universal concepts that any technological civilization would recognize, they maximized the chance of the signal being understood as artificial, even if detailed meaning remained opaque. The message might simply be, "We exist, we were here, we are intelligent," conveyed through the clearest possible language. Others argued the real message wasn't in the electromagnetic emissions at all. Perhaps 3i Atlas was a library, a data storage device carrying vast amounts of information in physical or chemical form within its structure. The mathematical broadcast was just an attention-getting mechanism, a way of saying, "Look closer, there's more here than meets the eye." If 3i Atlas was artificial, what exactly was it? The most compelling explanation emerging from the analysis was that the comet might be a von Neumann probe, a theoretical type of self-replicating spacecraft first proposed by mathematician John von Neumann in the mid-20th century. The concept was elegant and terrifying in its implications. A machine designed to travel between stars, arriving at new solar systems, gathering resources, creating copies of itself, and sending those copies onward to other stars. Von Neumann probes solve one of the fundamental problems of interstellar exploration. Even traveling at a fraction of light speed, crossing the distances between stars takes thousands or millions of years. No biological crew could survive such journeys without technologies we can barely imagine. But machines can wait. Machines don't need food or air or entertainment during the voyage. They can enter hibernation modes, power down to minimal levels, and drift through interstellar space for geological timescales before reactivating when they detect a target star system. The behavior of 3I Atlas fit the von Neumann profile disturbingly well. It had traveled from another stellar system, possibly spending millions or billions of years in transit. It remained dormant during that journey, appearing to outside observation as nothing more than a chunk of ice and rock tumbling through the void. Then, as it approached our sun and crossed some threshold of solar radiation or temperature, it activated. The mathematical broadcast began. The organized magnetic fields appeared. Something switched on after eons of silence. The unusual chemistry that had puzzled scientists from the beginning took on new meaning under the probe hypothesis. The extreme water production, the nickel without iron, the carbon dioxide dominance. These might not be natural characteristics at all. They could be byproducts of the probe systems, exhaust from power generation, or resource processing, materials being expelled as the probe performed whatever functions it was designed for. The comet-like appearance might be camouflage, or simply accumulated debris from billions of years drifting through interstellar space, coating the artificial core with ice and dust. Von Neumann probes are designed to be noticed eventually. Their purpose is exploration and communication, making contact with any intelligence that might exist in the systems they visit. The mathematical broadcast served that purpose perfectly, a universal signal that would be recognized as artificial by any species capable of radio astronomy and mathematics. Once noticed, the probe could assess whether the local intelligence was worth more detailed communication, or simply log their existence and move on. The self-replication aspect was more speculative, but potentially verifiable. If 3I Atlas was a von Neumann probe, it might attempt to gather resources from our solar system to build copies of itself. That would require mining asteroids or comets for raw materials, extracting metals and volatiles, manufacturing components. Such activities would be detectable if anyone knew to look for them. Some researchers began advocating for close monitoring of 3I Atlas's trajectory and any interactions it might have with other solar system objects. The probe hypothesis also explained the deep time perspective. A civilization wanting to explore the galaxy wouldn't send expeditions to specific targets and wait millions of years for reports. They'd launch self-replicating probes that would spread exponentially, each probe visiting a system and creating more probes that visited more systems. Given enough time, a single initial probe could spawn descendants that explored the entire galaxy. 3I Atlas might be part of a wave of exploration launched billions of years ago, one machine among millions scattered across the Milky Way. Not everyone believed 3I Atlas was primarily an exploration probe. An alternative hypothesis emerged from astrobiologists and origin of life researchers who saw the comet's chemistry through a different lens. What if 3I Atlas wasn't here to explore, but to deliver something? What if its purpose was seeding, deliberately spreading the building blocks of life across the galaxy? The directed panspermia theory proposes that advanced civilizations might intentionally distribute life, or its precursors, to suitable worlds, either to increase the probability of life emerging throughout the universe, or to ensure their biological legacy survives, even if they themselves go extinct. Rather than waiting for life to arise randomly through chemistry and chance, you actively spread the necessary ingredients to planets where conditions might support biology. 3I Atlas carried exactly those ingredients. The water production that had seemed so anomalous took on new significance under this interpretation. Water is essential for life as we understand it, the universal solvent in which biochemistry operates. 3I Atlas was hemorrhaging 40 kilograms per second, releasing vast quantities of this precious substance into space. Some of that water would eventually fall onto planets or moons in the inner solar system, delivery of a key component for potential biospheres. The organic molecules detected in the comet's emissions, the cyanide and carbon compounds that created its green glow, were prebiotic chemistry. Cyanide sounds toxic to human ears, but it's actually a crucial ingredient in the synthesis of amino acids and nucleotide bases, the building blocks of proteins and genetic material. Laboratory experiments recreating early Earth conditions consistently show that cyanide-containing compounds are essential steps in the chemical pathways leading to life. 3I Atlas was broadcasting these molecules into space wherever it went. The unusual composition, particularly the carbon dioxide dominance, fit the seeding hypothesis. Carbon dioxide provides carbon, the backbone element of organic chemistry and life. Combined with water and energy from sunlight or chemical reactions, carbon dioxide can be converted into the sugars and organic molecules that form the basis of metabolism. A seeding vessel would want to deliver carbon in forms that could be readily incorporated into emerging biochemistry. The mathematical signal served a different purpose under this interpretation. It wasn't primarily communication, but activation, a broadcast designed to trigger response or recognition in any intelligence that had evolved from previous seeding events. If a civilization sent panspermia vessels throughout the galaxy billions of years ago, some of those seeds might have grown into technological species by now. The Fibonacci and prime number patterns could be a test, a way of identifying which worlds had developed intelligence capable of recognizing artificial signals. 3I Atlas might be checking. Did our seeds grow here? Did they become conscious and technological? This theory explained why the signal didn't evolve or contain complex information. Its purpose wasn't to transmit knowledge, but to announce presence and assess intelligence. The real payload was biological and chemical, encoded in the comet's physical composition rather than its electromagnetic emissions. Analyzing the exact molecular inventory of 3I Atlas might reveal sophisticated organic chemistry, perhaps even encapsulated genetic material, designed to remain viable across interstellar distances and geological time. Some researchers proposed that Earth's own life might have originated from a similar delivery billions of years ago. If civilizations routinely seed suitable worlds, and if those seeding missions have been ongoing for timescales measured in billions of years, then the chemistry that sparks life on early Earth could have arrived on an interstellar comet much like 3I Atlas. We might be observing the same process that created us. While the world debated whether 3I Atlas was a probe or a seeding vessel, orbital mechanics specialists were discovering something that removed any remaining doubt about artificial intervention. The comet's trajectory was changing in ways that couldn't be explained by natural forces. It was maneuvering. Precise astrometry, measuring the exact position of celestial objects over time, requires patience and high-quality data collected across weeks or months. By late November 2025, enough observations had accumulated to model 3I Atlas's orbit with extreme precision. The results showed micro-deviations from the expected path, tiny adjustments inconsistent with simple gravitational influences and outgassing effects. Comets do change trajectories naturally. When gas vents from their surfaces, it creates thrust like a weak rocket engine, nudging the comet slightly off its predicted path. These outgassing forces are random and asymmetric, depending on which side of the nucleus happens to be active and how the comet is rotating. The trajectory changes are messy, unpredictable, with the comet essentially stumbling through space as different regions heat up and release gas. 3I Atlas wasn't stumbling. Its trajectory adjustments were precise, small course corrections that appeared at specific points in its orbit. The delta V, the change in velocity, was measured in centimeters per second, barely detectable but definitely real. More importantly, the corrections were directional, adjusting the comet's path in ways that kept it on a specific trajectory, rather than letting it drift randomly. Something was steering. The timing of the corrections correlated with the mathematical broadcast. When the signal intensity increased, when the Fibonacci patterns showed stronger emission pulses, the trajectory adjustments occurred. There was coordination between the broadcast and the maneuvering, as if both were controlled by the same systems activating together. Natural outgassing doesn't coordinate with emission patterns. Active propulsion systems do. Calculating the energy required for these maneuvers provided another clue. The measured velocity changes implied forces acting on a multi-billion-ton object, requiring significant energy expenditure. Where was that energy coming from? The magnetic field observations had already suggested active power systems operating inside the comet. The trajectory corrections confirmed those systems were capable of producing thrust, of converting stored energy into directed force. The maneuvering eliminated the last refuge of natural explanations. You could potentially argue that unusual chemistry produced coincidentally mathematical emission patterns. You couldn't argue that chemistry steered comets. 3I Atlas was under control, guided by something monitoring its path and making deliberate corrections to maintain its desired trajectory. It wasn't drifting through our solar system by chance. It was navigating, and that changed everything about what humanity was confronting. Orbital calculations revealed something that sent chills through the research teams. 3I Atlas's trajectory was bringing it into a precise celestial alignment on October 31st, 2025. On that date, the comet would position itself along a direct line connecting Earth, the Sun, and the galactic center. The timing felt deliberately theatrical, and the signal intensity was increasing as the alignment date approached. Astronomical alignments happen regularly by chance. Planets line up, eclipses occur, objects pass in front of each other from our perspective. The universe is full of moving bodies, and occasional alignments are inevitable given enough time. But 3I Atlas wasn't just passively participating in a random alignment. Its trajectory corrections were steering it toward this specific geometric configuration, and the date happened to fall on a culturally significant day in Western calendars, though that was almost certainly coincidence. What made the alignment significant wasn't the date, but the geometry. The galactic center, located roughly 26,000 light-years away in the direction of Sagittarius, represents the gravitational and geometric heart of the Milky Way. If 3I Atlas originated from the thick disk, its home region orbits around that same galactic center, creating an alignment that connected the comet, our Sun, Earth, and the galactic center, created a geometric relationship pointing back toward its origins, like an arrow drawn across space. The signal intensity increases added urgency to the situation. Monitoring stations worldwide were detecting stronger emission pulses as October 31st approached. The Fibonacci timing remained precise, but the amplitude of each pulse was growing. The visible light brightness variations were becoming more pronounced. The magnetic field fluctuations were increasing in strength. 3I Atlas was ramping up its output as if building toward something, and the alignment date was the obvious trigger. Scientists scrambled to predict what might happen when the alignment occurred. Would the signal intensity peak and then decline? Would new patterns emerge? Would the probe attempt some kind of transmission specifically timed to the geometric configuration? Or was the alignment itself the message, a demonstration that the object could navigate with precision and understood astronomical geometry well enough to create meaningful spatial relationships? The public was equally fascinated and anxious. October 31st carried cultural baggage, associations with darkness and mystery that made the timing feel ominous, even though the date meant nothing to an interstellar probe. Social media filled with speculation, ranging from scientific to apocalyptic. Some people planned observation parties to watch the alignment. Others retreated into fear about what an alien artifact might do when it reached its destination. Everyone was waiting for October 31st to see what 3I Atlas had planned. As October 31st approached, the international community's response to 3I Atlas fractured along predictable geopolitical fault lines. What began as scientific cooperation deteriorated into competing national interests and fundamental disagreements about how humanity should respond to what appeared to be first contact with alien technology. The United Nations Security Council convened emergency sessions to discuss coordination and protocols. The United States delegation argued for quarantine measures, proposing that no nation should attempt direct communication or approach missions without international consensus. Their position emphasized caution, citing concerns about unknown risks and the need for unified human response rather than fragmented national initiatives. Critics suspected the real motivation was maintaining control and preventing other nations from gaining technological advantages through independent contact. China took the opposite stance. Having already demonstrated willingness to share observations publicly through the Tiangong footage, their representatives argued that attempting communication was both scientifically valuable and ethically necessary. If 3I Atlas was broadcasting a signal designed to be noticed, refusing to respond seemed counterproductive. They proposed coordinating a reply transmission using the Tiananmen radio telescope, a powerful facility capable of sending signals that the probe could potentially detect. The European Space Agency found itself caught between these positions. Internal divisions mirrored the international disagreement, with some member states supporting the American caution approach, while others leaned toward the Chinese communication initiative. ESA's official position became increasingly vague, calling for continued observation and analysis while avoiding commitment to either camp. The diplomatic paralysis frustrated scientists who wanted clear direction about what research was permitted and what crossed into politically sensitive territory. Russia complicated matters further by announcing they possessed classified observational data not shared through international channels. They hinted at discoveries that went beyond what other nations had published, but refused to provide details, claiming national security concerns. Whether this was genuine intelligence or strategic posturing remained unclear, but it poisoned the collaborative atmosphere that had characterized early observations. India, Japan, and other spacefaring nations, with their own observation capabilities, began hedging their positions. Some aligned loosely with existing power blocks, while others declared independent research programs, answerable only to their own governments. The unified human response that idealistic scientists had imagined evaporated into competing national projects with minimal coordination. The fracturing extended beyond governments. Private space companies started announcing their own intentions. Some proposed sending spacecraft to intercept 3I Atlas. Others suggested communication attempts using privately owned transmission facilities. The legal frameworks governing such activities were ambiguous at best, and no international body had clear authority to prevent non-governmental entities from taking independent action. By late October, humanity's response to potential first contact looked less like coordinated species-level decision-making and more like chaotic competition among rival factions. On October 29, 2025, just 2 days before the predicted alignment, a team of mathematicians achieved a breakthrough that transformed understanding of what 3I Atlas was communicating. The Fibonacci and prime number patterns weren't just demonstrations of intelligence. They were encoding coordinates, a mathematical description of the probe's origin point in three-dimensional galactic space. The insight came from recognizing that the pattern wasn't simply repeating, but progressing through a sequence with specific numerical relationships. When the researchers plotted the Fibonacci numbers against the prime numbers in multi-dimensional space, geometric structure emerged. The ratios between successive values created angles. The progression through the sequences traced paths. Together, they formed a coordinate system describing position relative to the galactic center. The mathematics was elegant and universal. Any civilization with astronomy would understand galactic coordinates. Any species with mathematics would recognize Fibonacci and primes. Combining them created a location marker that didn't depend on arbitrary units or cultural conventions. The probe was saying, "Here's where I came from," expressed in pure mathematical relationships that worked regardless of whether you measured distances in light years or parsecs or units that humans had never conceived. Triangulating from the coordinate information pointed to a specific stellar region approximately 2,400 light-years away in the constellation Cygnus. The target area contained hundreds of stars, too many to identify a single origin system without more detailed analysis. But narrowing the probe's birthplace from the entire galaxy to a specific neighborhood of a few hundred stars was extraordinary progress. Astronomers immediately began searching databases for everything known about that region. Were there unusual stars that might host advanced civilizations? Were there signs of megastructures or other technosignatures that previous surveys might have missed? The region was well mapped by conventional standards, but nobody had been looking specifically for evidence of technological activity. Reanalysis with that question in mind might reveal clues that had been overlooked. The coordinate decoding also confirmed the probe's intentionality. 3I Atlas wasn't just broadcasting mathematical patterns to demonstrate intelligence. It was providing actionable information, telling humanity where to look if they wanted to learn more. This was communication with purpose, a message containing actual content beyond simple "here I am." The probe was extending an invitation, or at least providing context about its origins. Most significantly, the coordinate information suggested the civilization behind 3I Atlas wanted to be found, or at least wanted their location known. They weren't hiding. They'd sent a probe across interstellar space, carrying a map home. Whether that civilization still existed after the billions of years since launch was unknown, but they'd left a trail pointing back to their stellar neighborhood, encoded in mathematics that would survive longer than any language. Within hours of the coordinate decoding being leaked online, amateur astronomers worldwide began pointing their telescopes toward the indicated region in Cygnus. What they found there sparked an entirely new wave of speculation and raised profound questions about what humanity was actually dealing with. The target coordinates centered on a relatively unremarkable G-type star similar to our Sun, catalogued but never studied in detail. Amateur observers with modest equipment couldn't resolve planets or surface features, but they could measure the star's light across different wavelengths. Multiple independent observers detected an anomalous infrared excess, meaning the star was emitting more infrared radiation than its visible light output would predict. Infrared excess typically indicates warm material surrounding a star, usually a debris disk of dust and rocks left over from planet formation. But the infrared signature from this Cygnus star had unusual characteristics. The temperature profile didn't match natural dust clouds. The emission spectrum showed specific features that looked almost engineered, with sharp boundaries, rather than the smooth gradients expected from diffuse material heated by starlight. Within the amateur astronomy community, comparisons to Dyson swarm signatures began circulating immediately. A Dyson swarm is a hypothetical megastructure, millions or billions of solar collectors orbiting a star to harvest its energy output. Such a structure would absorb visible light and re-radiate it as infrared, creating exactly the kind of anomalous signature the observers were detecting. The idea had been theoretical speculation for decades, but now there was potential observational evidence pointing to the same stellar system that 3I Atlas had encoded in its signal. Professional astronomers were initially skeptical, pointing out that infrared excess alone doesn't prove artificial structures. Natural explanations like asteroid collisions or cometary impacts could temporarily create similar signatures. But as more observers contributed data and the measurements became more refined, the skepticism began eroding. The infrared emission was stable over the observation period, not varying like you'd expect from transient natural events. The spectral features remained consistent, suggesting permanent structures rather than temporary dust clouds. The timing felt impossibly coincidental. 3I Atlas arrives broadcasting mathematical patterns. Those patterns encode coordinates. Amateur observers point telescopes at those coordinates and immediately find infrared anomalies consistent with megastructure signatures. Either this was the most remarkable coincidence in astronomical history, or 3I Atlas was deliberately directing humanity's attention to its home system, a system that showed evidence of large-scale engineering. The discovery added another layer of validation to the artificial probe hypothesis. Not only was 3I Atlas exhibiting technological characteristics, it was pointing toward a stellar system that also showed potential technological signatures. The probe and its origin were telling a consistent story, one that suggested a civilization with capabilities far exceeding human achievement. The discoveries in Cygnus intensified a debate that had been simmering since the patterns were first detected. Should humanity respond to 3I Atlas? And if so, what should we say? The question divided scientists, philosophers, and the public into camps with fundamentally different views about risk, opportunity, and humanity's place in the cosmos. Stephen Hawking had warned about this exact scenario years before his death. His argument was straightforward and chilling. Advertising our presence to unknown intelligences could be catastrophic. History shows that when technologically advanced civilizations encounter less advanced ones, the results are rarely good for the less advanced. If 3I Atlas represented a civilization capable of interstellar travel and billion-year engineering projects, humanity would be hopelessly outmatched in any conflict. Responding might be inviting conquest, or worse. The counter-argument was equally compelling. We were already visible. Earth had been broadcasting radio and television signals into space for over a century. Our atmosphere showed chemical signatures of industrial civilization, detectable by any species with spectroscopy. If 3I Atlas could navigate to our solar system and detect our sun, it could certainly detect that we were here. Staying silent now was closing the barn door after the horses had escaped. We'd already been noticed, or we wouldn't be having this conversation. The Meat-Eye debate, messaging to extraterrestrial intelligence, had raged in academic circles for decades without resolution. Active Meaty advocates argued that listening passively for alien signals while never transmitting our own was selfish and counterproductive. If every civilization stayed silent, waiting for others to broadcast first, nobody would ever make contact. Someone had to take the first step, and perhaps 3I Atlas arriving in our solar system was the universe's way of forcing that step. Opponents insisted that the decision to broadcast on behalf of all humanity shouldn't be made by small groups of scientists or governments without global consensus. Responding to 3I Atlas was potentially the most consequential decision in human history, affecting every person on Earth and all future generations. It required democratic deliberation and universal agreement, which was effectively impossible given humanity's political fragmentation. China's announced intention to transmit a response using their radio telescope brought the debate to a crisis point. Other nations couldn't stop them from broadcasting, and once one transmission went out, the taboo would be broken. Multiple countries and private entities would likely follow with their own messages, creating a chaotic chorus of competing signals, rather than any coherent human response. Some scientists argued the debate was already obsolete. If 3I Atlas was actively maneuvering and responding to solar proximity, it knew there was a technological civilization here. The probe itself might be gathering data about Earth, monitoring our broadcasts, assessing our capabilities. The question wasn't whether to reveal ourselves, but what message we wanted to send now that we'd been found. Silence was a message too, one that might communicate fear, hostility, or lack of sophistication. November 2nd, 2025, 2 days after the predicted alignment, 3I Atlas did something it had never done before. The pattern changed. After weeks of broadcasting the same Fibonacci and prime number sequences with mechanical consistency, the signal evolved into something new, and the implications were staggering. The change was detected simultaneously by monitoring stations worldwide. The familiar Fibonacci timing intervals continued, but overlaid on them was a new structure, a secondary pattern that hadn't existed before. The emission pulses now contained modulation, rapid variations within each burst that created what looked almost like a carrier wave with information encoded on it. The signal had gone from simple mathematical demonstration to something approaching actual data transmission. Analysis of the new pattern revealed it was responding to observation. The secondary modulation incorporated elements that mirrored Earth's own broadcasts. Specific frequency ratios matched those used in human radio and television transmission standards. Timing structures echoed patterns from digital communication protocols. 3I Atlas wasn't just blindly broadcasting anymore. It was acknowledging that it had been noticed and adapting its signal to resonate with the technological signatures it had detected from Earth. This was the confirmation that changed everything. The probe wasn't a passive beacon or a mindless recording playing on an endless loop. It was actively monitoring its environment, detecting the electromagnetic noise of human civilization, and modifying its output in response. Something inside that comet-like shell was awake, aware, and attempting communication on terms it thought humanity might better understand. The response arrived exactly 48 hours after the October 31st alignment, suggesting the geometric configuration had indeed been significant. The probe had waited until it achieved the specific celestial positioning, perhaps using that alignment to calibrate its understanding of the solar system's structure and the position of technological activity within it. Once aligned, once calibrated, it shifted from announcement mode to conversation mode. Scientists scrambled to analyze the modulated signal, searching for meaning in the new patterns. Was this actual language, or still mathematical demonstration, at a higher level of complexity? Were the frequency ratios random selections from detected broadcasts, or deliberately chosen to convey specific information? The analysis would take days or weeks, but the immediate implication was undeniable. 3I Atlas knew it was being watched and had decided to change its approach. The evolution of the signal meant the debate about whether to respond became irrelevant. 3I Atlas was already responding to humanity's presence and activity. The conversation had begun, whether anyone officially sanctioned it or not. The probe had made first contact, acknowledged Earth's technological civilization, and invited dialogue by adapting its transmission to match human communication signatures. The question was no longer if humanity should respond, but what to say now that someone was clearly listening. A microbiologist reviewing the chemical composition data proposed a radical reinterpretation that tied together everything strange about 3I Atlas. The mathematical patterns weren't messages in the traditional sense. They were instructions, digital encoding of biological information. The comet wasn't broadcasting language, it was broadcasting genomes. The theory emerged from analyzing the specific molecules being emitted alongside the mathematical patterns. The organic compounds weren't random selections from cometary chemistry. They included amino acids in ratios that looked optimized for protein construction, nucleotide bases that form DNA and RNA, and complex organic structures that serve as chemical building blocks for life. 3I Atlas was releasing a molecular toolkit for biology. What if the Fibonacci and prime number sequences weren't communication but data structure? Digital information requires organization, headers, and markers that indicate where data begins and ends, checksums that verify accuracy. The mathematical patterns could be serving that function, providing a framework for encoding vastly more complex biological information within the chemical and spectral emissions. This interpretation made the directed panspermia hypothesis suddenly more concrete. 3I Atlas wasn't just scattering prebiotic molecules, hoping they'd randomly assemble into life. It was delivering blueprints, genetic instructions, that any sufficiently advanced recipient civilization could decode and potentially reconstruct. The probe was a seed bank, carrying encrypted biological data that could survive the journey across interstellar space and geological time. The implications were breathtaking. If the theory was correct, humanity now possessed the genetic information from another biosphere, possibly instructions for creating alien organisms, or at least understanding how life evolved in a completely different stellar system. Decoding that information would require connecting the mathematical patterns to the molecular emissions, treating the entire signal as one integrated data transmission, where numbers provided structure and chemistry provided content. The microbiologist's proposal also suggested why the signal evolved after the alignment. The probe had assessed Earth's technological capabilities through our broadcasts, determined we might be sophisticated enough to understand biological encoding, and switched to a transmission mode that emphasized the chemical components. It was trying to direct our attention from the mathematical carrier to the molecular payload, essentially saying, "You noticed the pattern. Now look at what the pattern contains." 3I Atlas was approaching perihelion, its closest point to the Sun, predicted to occur in 3 weeks. Orbital calculations placed that moment in late November 2025, and every model suggested the comet's activity would reach maximum intensity at that point. Whatever 3I Atlas was designed to do, perihelion might be when it happened. Solar heating increases exponentially as objects approach the Sun. At perihelion, 3I Atlas would receive maximum energy input, warming its surface and interior to temperatures far higher than during its long approach. If the probe's systems required power beyond what internal sources could provide, perihelion offered the opportunity to harvest solar energy at peak efficiency. The timing suggested the probe's designers had planned for this moment. Scientists monitoring the signal intensity confirmed the pattern was continuing to strengthen. The emission pulses were growing more powerful daily as the comet moved sunward. The magnetic field variations were increasing in amplitude. The visible light modulations were becoming bright enough that observers with even modest telescopes could detect the pulsing without specialized equipment. 3I Atlas was building towards something, and perihelion was the obvious culmination. several scenarios dominated speculation about what might occur. Perhaps the probe would release something at perihelion, deploying secondary devices or transmitting a final data burst at maximum power. Perhaps it would undergo physical transformation, with components that had remained dormant during approach finally activating when energy availability peaked. Perhaps perihelion represented a decision point where the probe assessed whether this solar system was worth extended investigation, or whether it should continue outward after its brief visit. More concerning scenarios involved the probe attempting to gather resources at perihelion. The inner solar system contained abundant materials for any device capable of mining and processing asteroids or comets. If 3I Atlas was a von Neumann probe designed to self-replicate, perihelion positioned it optimally to begin resource extraction before departing to seed copies throughout the system. The worst-case scenarios imagined threats. Perhaps the probe's mission included planetary assessment followed by sterilization if technological civilizations were detected. Perhaps perihelion triggered weapon systems or terraforming mechanisms designed to prepare worlds for occupation. These fears were speculative, but couldn't be completely dismissed, given how little was actually understood about the probe's purpose. Everyone was watching the calendar count down to late November. 3 weeks until perihelion. 3 weeks until 3I Atlas reached its moment of maximum power and activity. 3 weeks until humanity discovered what the probe had traveled billions of years to accomplish. Behind the press conferences and academic papers, behind the diplomatic meetings and public speculation, the discovery of 3I Atlas was doing something profound to the people most directly involved in studying it. The existential weight of potentially encountering alien intelligence was transforming lives, challenging beliefs, and forcing confrontations with questions humanity had debated for millennia without ever expecting to need real answers. Career implications weighed heavily on junior researchers. A postdoctoral fellow working on spectral analysis found herself paralyzed by the awareness that her name would forever be associated with either the most significant discovery in human history or a spectacular misinterpretation that became a cautionary tale. Every data point she reported, every conclusion she drew, might be scrutinized for generations. The pressure was crushing. She started experiencing anxiety attacks during observations, terrified of making mistakes that would discredit legitimate findings or endorsing conclusions that later proved embarrassing. Senior scientists faced different struggles. A 70-year-old astronomer who had spent 5 decades studying comets confronted the possibility that everything he thought he understood about these objects might be incomplete. If 3I Atlas was artificial, how many other supposed comets were actually probes? Had his entire career been built on assumptions that were fundamentally wrong? The crisis wasn't professional, but philosophical. A lifetime of certainty dissolving into uncertainty. The religious implications provoked intense personal reckonings. A devout Catholic astronomer working at the Vatican Observatory struggled to reconcile church teachings about humanity's special place in creation with evidence of intelligence older and more advanced than our species. She spent nights reading theological texts about the plurality of worlds, searching for frameworks that could accommodate alien intelligence without undermining her faith. Some colleagues found their beliefs strengthened, seeing 3I Atlas as evidence of God's creative abundance. Others experienced crises that drove them away from religion entirely. public reaction spanned every conceivable emotional response. Some people experienced euphoria, feeling that humanity had finally broken through cosmic isolation to discover we weren't alone. They organized celebration events, created art inspired by the signal, and treated the discovery as humanity's graduation into galactic citizenship. Others descended into existential dread, confronting the terrifying possibility that we were cosmically insignificant, one species among perhaps millions, children playing with fire while adults watched from the darkness. Denial was a common coping mechanism. Despite overwhelming evidence, significant portions of the population simply rejected that 3-Eye Atlas could be artificial. They clung to increasingly implausible natural explanations, or dismissed the entire situation as government conspiracy and media manipulation. The denial wasn't stupidity, but psychological protection, refusing to accept information that shattered comfortable worldviews about humanity's uniqueness and safety. Families divided over the implications. Parents argued with children about whether the discovery was dangerous or wonderful. Marriages strained under disagreements about what 3-Eye Atlas meant for humanity's future. Some people quit their jobs to focus on what they saw as humanity's most important moment. Others retreated into normalcy, deliberately ignoring the news because the implications were too overwhelming to process while maintaining everyday routines. Mental health professionals reported increased anxiety and depression related to the discovery. Therapy sessions filled with people trying to articulate fears they didn't fully understand. Existential questions about meaning and purpose when humanity might be just one small voice in a vast cosmic conversation. Support groups formed for people struggling to cope with what one psychologist called cosmological grief, the loss of the familiar universe where we thought we were alone. 3-Eye Atlas had become more than an astronomical object. It was a mirror forcing humanity to see itself differently, and not everyone was ready for that reflection. The signal continues. As this story reaches you, 3-Eye Atlas is still broadcasting its mathematical patterns into the void, still pulsing its Fibonacci sequences and prime numbers across the electromagnetic spectrum, still maneuvering through our solar system with purpose and precision. The transmission hasn't stopped, the questions haven't been answered, and humanity stands at a threshold we never quite believed we'd reach. Whether 3-Eye Atlas is a von Neumann probe, a biological seeding vessel, or something we haven't imagined yet, the fundamental reality remains unchanged. An object arrived in our solar system, carrying intelligence from somewhere else, from somewhen else, and it's trying to communicate. For the first time in human history, we're not alone in the conversation, we're receiving. The scientific analysis continues around the clock. Teams are still decoding the evolved signal patterns, still searching for biological information in the molecular emissions, still monitoring the trajectory adjustments and magnetic field variations. Every day brings new data and new mysteries. The perihelion approach in late November looms as a deadline, a moment when everything might change, or when nothing happens except the comet swings around the sun and continues its journey back into interstellar space. But something has already changed, something irreversible. Humanity crossed a line the moment we recognized those patterns as artificial. We stopped being a species that wondered if we were alone and became a species that knows we're not. That knowledge changes everything, even if we never learn another detail about 3-Eye Atlas or its creators. The telescope arrays remain pointed at that region in Cygnus, searching for more evidence of the civilization that might have built this probe billions of years ago. The infrared anomalies are being studied with every available instrument, trying to determine if we're really seeing megastructures or just wishful thinking imposed on ambiguous data. Plans are being drafted for future missions, spacecraft that might intercept 3I Atlas or its descendants, instruments that could sample its surface or decode its payload more completely. And through all of this, the pattern continues. 1.3 seconds, then 2.6, then 3.9, counting through Fibonacci intervals with mechanical precision. 2 milliseconds, 3 milliseconds, 5 milliseconds, marking prime numbers in the duration of each pulse. The mathematics of the universe, written in light and magnetism, broadcast by an object that traveled farther and longer than human civilization has existed. We built radio telescopes and space stations to listen for signals from the stars, to catch whispers from distant worlds, to find evidence that intelligence existed somewhere in the cosmic dark. We pointed our instruments outward, and we waited, hoping for decades that someone would answer. And then the answer didn't come from out there. It came to us, traveling physically across the galaxy, arriving at our doorstep like a message in a bottle that drifted for ages before washing ashore. 3I Atlas is speaking, and we are listening. The conversation might be one-sided, the message might be incomprehensible, the sender might be extinct or transformed beyond recognition. None of that changes the essential miracle of the moment. We asked if anyone was out there. Something answered. And now, whether we're ready or not, whether we understand or remain confused, whether we respond or stay silent, we're part of something larger than ourselves. The signal continues. We are receiving, and the universe will never feel empty